addition and subtraction of rational expressions. If you think back to fractions, remember that addition and subtraction is the place where you have to have a common denominator. The denominator's job is it describes what kind of piece you have, so it has to be the same in order to add or subtract them. Once you have it the same, then you combine the numerators and will reduce at the end. So first we'll look at a few problems that already have a common denominator. If you have one already, you go ahead and put it in the answer. You don't do anything else to it. Combine on the numerator. You have to watch your signs on the numerators. This time they're both positive, so that's easy. And then the last step is you see if it will reduce. And this problem will not reduce. Our next problem also has a common denominator already. So we'll go ahead and put it in the answer, x minus 1. Combine the numerators. They're both positive, so we'll just add, keep it positive, and there is nothing to reduce. For this problem, we are adding our rational expressions. They have a common denominator. We will keep that, put it in the answer. We will combine the numerator. These are not like terms, so you can't really combine. All you can do is write them on the same line. And our last step is to see if we can reduce. Remember, to simplify or reduce these rational expressions, you have to see if they will factor. On the numerator, we can take out a GCF. We can take out a 2, and that leaves x plus 5. The denominator, there's nothing we can do. The exponent is 1. There's no GCF. But we did get a common factor. The x plus 5 will divide out, and it leaves us 2. Our next problem is a subtraction of rational expressions. Works exactly like addition. You just watch your signs. So we make sure about a common denominator. We have it. Put it in the answer. Combine on the numerators. They're not like terms, so all you can do is write them on the same line. And then we have to see if it will reduce. So we have to try to factor. On the numerator, we can take out a GCF of 4. That leaves x minus 3. Denominator, there's nothing you can do. The exponent is 1, and there's no GCF. But we did get a common factor here. The x minus 3 will divide out and leaves us 4. This problem is one that we have to be a little bit more careful on because that subtract is going to apply to the entire second numerator. All right, let's go ahead. We're subtracting fractions. We have a common denominator. We'll keep it, put it in the answer. And then our next step is combine numerators. But as soon as we see it's subtraction, if we take time to distribute that sign to each piece in that second numerator, then we will be saved. So I'm going to carry the first one over. Right, then I will have a minus x and a minus 1. Now let's see what will actually combine there. Notice that your x's will cancel out. Positive x and minus x cancel. Negative 1 and negative 1 actually add because they're like signs. So add and keep the sign. This problem will reduce. You have a common factor of 2, and this is a monomial. It's already a product. So we can divide by 2. It's still going to be negative. Remember, when everything divides out of the numerator, to write a 1. For this problem, we are adding fractions. They already have a common denominator. Keep it, put it in the answer. Combine on the numerator. And these are not like terms, so they can just go on the same line. You have to see if this will reduce. Your denominator will factor. This is a difference of squares. And then you can simplify. The x plus 1 will divide out. Remember, when everything divides out of the numerator, it goes 1 time. So we have 1 over x minus 1. For our next problem, we are subtracting fractions. We do have a common denominator. Looks a little bigger than we've been seeing, but that's okay. It's already the same, so we go ahead and put it in the answer. We will combine on the numerators. Remember, this one is a subtract, and this subtract will affect everything in that second numerator. So it's going to give us a minus x and a plus 8. You can go ahead and combine right there, or you can carry them all over here and then combine. It doesn't matter. I'll just carry them over. And then I will combine. So I have 2x minus x is x. On my constants, I have different signs. Subtract sign of the larger. I need to see if my denominator will factor. So we're going to do like signs, both minus. And we could do 6 times 2. Would multiply to give 12, add to give 8. Then we look back to see if we can reduce, and we can. We can divide out the x minus 2. So that will leave us a 1 in the numerator. 1 over x minus 6. One last problem in this part. We're adding fractions. We have the common denominator. Keep it, put it in the answer. Combine on the numerator. This one is addition, so it's not going to change anything in our second fraction. So we'll go ahead and just combine. So we have 7x and minus 8x will leave us a minus 1x. And we have minus 9 plus 2, different signs, subtract sign of the larger. Right, in the denominator, we'll go ahead and factor that. And 6 and 7 are going to work. We need the 7 with the plus to get back a positive 1. So that works. Now, for the numerator, because it starts off with a negative, we could factor out a negative GCF if that helps us. And that would change all the signs and make it match. So let's do that. We're taking out a negative 1. It's going to change all our signs. It will leave us a positive x and a plus 7. Let's double check that. If we multiply it back, that would be negative x, negative 7. So what we did is okay. And now we do have something that will match that we can divide out. So we're left with negative 1 over x minus 6. If you do not have a common denominator, you must find one. For your denominators, if they have no common factor, then the LCD, or least common denominator, will be the product of the two. So this LCD will be 3 times 4, which is 12. So we're going to have 12 for an LCD. That means we want to get 12 on the denominator for both of these. We're going to need to work on each fraction. So we look at the denominator to decide, and our first one is missing a factor of 4 to get 12. You are required to put it on the numerator and denominator. That way you're multiplying by 4 over 4, which is really 1. That's what makes it okay to do. It will give you back something equivalent. Right? For the other fraction, we have a 4. We would like to get 12. It is missing a factor of 3. Put it on numerator and denominator. Now, let's clean those up. So this gives us 8 over 12 plus 9 over 12. And now we're set. We have the common denominator. They're just like before. So keep the common denominator, combine the numerators, and this will not reduce. For our next problem, we have to find a common denominator. Right? These two denominators do have a common factor. I would actually always check, does that smaller one divide into the larger one? It does, so you're going to use the larger one. So we can use a 6 for the common denominator. But let's go through the steps in case that didn't happen. Since they have a common factor, break it down into primes. So for 6, it's made out of 2 times 3, and here we have a 3. You have to have every type of factor that's there. You take it from the one fraction where it occurs the most. So in our LCD, we need 2's and 3's. The 2 will come from this one because there's no 2's in the other. The 3's are the same amount in each one, so you will only take one of them. If one has more, you would take the one with more. And that gives you the 6. If you can see that one divides into the other one, take that little shortcut. But if not, this is a technique that works. Let's go ahead and work on these fractions and actually get equivalent fractions with the 6 as the LCD. The first fraction is actually done. It already has a 6 in the denominator, so just bring it down. The second fraction, we have a 3. We would like to get a 6. You're missing a factor of 2. Put it on. Remember, it's numerator and denominator. So we have 4 over 6. And now we can combine. So we will keep our common denominator. Combine on the numerator. 5 minus 4 is 1. This will not reduce. For this problem, let's see about a common denominator. If we just look at the numbers 5 and 7, they do not have anything in common. So we're going to need both of them. 5 times 7 is 35. All right, and we also have to cover the y. There is one y in each one, so we will need one y. You have to have every type of factor that occurs, and you take it from the one where it occurs the most. They're tied, so we just take it from one of them. Right, so our common denominator is going to be 35y. We will check the denominators and put on the missing part. So for the first fraction, looking at the denominator, we have the 5 and the y. This one is missing the 7. Numerator and denominator. The second one, we have the 7 and we have the y. This one is missing the 5. Put it on, numerator and denominator. Now we'll rewrite this. So we have 8 times 7 is 56 over 35y plus 15 over 35y. Keep your common denominator and combine the numerators. And I don't think that is going to reduce. For our next problem, our first job is to find the common denominator. If we look at our numbers 2 and 3, those are both primes. They have nothing in common. We are going to need both of them, so we will need the product of them. For the y's, we have y in both. It's the same kind of factor. This is just 2 y's and this is 1 y. You will take it from the one with the most. So we are going to need 2 y's, or a y squared, for our LCD. Right, now we'll work on each fraction and put on the missing part. So for our first one, we have the 2 and the y squared. We are missing the 3. Put it on numerator and denominator. For the second one, we have a 3 and we have one of the y's. So we're missing a 2 and one more y. Put it on numerator and denominator. Now we'll multiply out, so we have 9 over 6y squared plus 14y over 6y squared. Keep your denominator and combine your numerators. These will not actually combine because one has a y and one does not. All you can do is write them on the same line. If you wrote the other order, that's okay. Now, I cannot take anything off of that numerator because it is not a product, so I can't take a piece off. So I can't reduce with the y's, I can't reduce with the 6 and 9, so I need to leave it here. For this problem, we do have a common factor in those denominators, so we're going to need to build up our LCD. The 3 will actually divide into the 12, so we can use the 12. For your x's, we have x in both, Remember, take it from the one with the most. So we will need to take an x squared. So for our first fraction, we have the 12. We have one x. We need one more x. For the second fraction, we have a 3, but we want a 12. So this one needs a 4. It is okay with the x squared. It already has the x squared. So we have 5x over 12x squared plus 28 over 12x squared. Keep the denominator and combine the numerators. They can't really go together because one has x and one does not. So there is nothing you can do there. Again, this is one that you are not allowed to reduce because your numerator is not a product. You cannot take a piece off of there. If it would factor, you could factor. This numerator does not factor. There's no GCF, so there's nothing else that we can do.